Hi guys, we are going to look at counting a manual cell count using a hemacytometer. Now normally this is something you will have under a microscope. It's definitely much more difficult counting and focusing to find the cells under the microscope. So this actually should be pretty easy, but I do want to go over some basic rules with you. And the calculation, of course. We're going to try to understand the calculation as much as possible. Okay, so what we're going to see here is when we start counting, these are pretending these are white blood cells, so they're larger. Usually it's a little easier to count the larger ones, so we are going to start and we're going to count the 4 large squares. Now I'm going to draw, let's try highlighting it so you can see a little better. These are going to be our large squares. Okay, 1, 2, 3, 4, and here's our 4th one. Okay, so again, typically for white blood cells, we're going to count the 4 large squares. Okay. When we count, we're going to look at these, and I'm actually going to change colors here, because when we count these cells, we want to count the cells that are inside or touching the top of the square and the left of the square. When we're in that square, we're not going to actually count the cells that are touching the right or the bottom. Okay, so let's go, and we do this methodically so you don't lose track of where you're at. When you start doing this, you're going to realize there's a lot of cells there. This is a lot larger under the microscope, and you can get lost really easily. So we have a method. So we start right here in this square, and when we count, we're going to go across this way, then we're going to go down, across this way, down, across this way, down, and across. Okay, that's one square. Now we're going to go to this square, this way, down, over. Okay, and you keep this. Once you have a method formed and you stick with it, then you tend to not get lost. Okay, and the problem is getting lost. So let's count these cells. So let's go back here. I'll put my highlighter on. We'll make it another color so we can see. And we're going to count, whoops, I'm sorry. We'll go ahead and count this one as 1. It pretty much is in this box. Okay, so we'll count it 1. And we're going to go across here. Now we don't count this cell in this box. Okay, now when we go down to this box, it's on the top and the left, so now we're going to count it as 2. We're going to go across, no cells. Okay, when we come down here, now we're going to count this one as 3 because it's touching the top line. Okay, so 3. We'll go 4. This one is 5, and we're going to go across. Okay, so that's 5. We have 5 cells in this box. We do not count this one. Okay, when we are in this box right here, it is not touching the top or the left, it's touching the bottom. Okay, and we're not counting that. And this is consistency. Okay, because there'll be a cell in another box that's touching that will count. Okay, so we just need to make sure we stay consistent. So let's go over here. We'll go across here. Again, we're not going to count this one. It's touching the right. It's not the top. It's not the left. You could argue that it's mostly in here. So if you want to count it, one cell's not going to be that detrimental. But you're going to see when you're actually counting real cells, they're not going to be this big compared to your line. So you wouldn't end up counting it. So because it's on the line, we're going to stick with our consistency, and we're not going to count that cell. Okay, so now we'll go down, we'll count 1, now we'll count this one 2, okay, we'll count this one, it's on the line, we're going to count it because this one we didn't, so you see where this is going, where our consistency, 1, 2, 3, and 4. Okay, so we have 4 in here. Now we're going to go down and we're going to do this one. We don't count that one yet. 1, 2, we'll go ahead and count it now, 3. Whoops, that's funny. Okay, we'll go across 4, 5, and that's when we're done on this one. Again, this one is on the bottom, so we're not going to count that. So we have 5. So let's go over here. This one we're really, it's touching the top line, and it's the majority of it's in there. So we're going to go 1. Now we have a tricky one. This is actually touching the top line here, so we're going to go ahead and count that one. 2, 3, 4, and then we have 5 cells. Okay. The other thing when you're counting a hemacytometer, you're actually going to have 2 sides. So when you have your hemacytometer, it looks a little bit more like this, and you have 2 sides. So this grid is etched onto your hemacytometer on both sides. So you count those, and these counts from this side and this side need to match. Depending on where you're working and the calculations they have you to do, in the procedure in the lab, there are 2 different ways. There's percent difference, and then there's also the standard deviation calculation. Most of the places I've worked, we've always calculated a percent difference. And so, like if one side was 7 and one was 5, that was acceptable. And typically we would say if it's below 10, they have to be plus or minus 2 cells, something along those lines. Everywhere you go is going to be a little different. But they have to match, because you can't have counts, okay, that are 25 on this side and 2 over here. That doesn't match. There's something wrong. You didn't load your hemacytometer right, you overflowed it, something's wrong, and you're going to have to recount that. Okay, so they have to match. Okay? So typically you're going to be counting 2 sides. We don't have 2 sides to count. I didn't draw it like that for you, so we're going to go ahead and we're just going to do our calculations from one side. Okay? If you had 2 sides, the calculation that I have at top, I wrote it right here. Okay, whoops, it's right here at the top. Shows you to average the cells. Okay, so there's 2 different ways you can do that, and that average would be the average of those 2 sides. So if you had, 7 and 5, your average would be 6. I picked an easy one on purpose. Okay, so there's not 2 ways to average, but there is 2 ways to do this count, and I'll show you that too. Okay, so let's get started with this count. The other thing you have to know is the volume of these squares. And I can hop you over to the procedure real quick right here, and I can show you the volume on these. Okay, we're going to just go ahead and highlight it. So when you're counting those 4 large squares, that volume of that large square is 0.1. Okay. When we count red blood cells, I'll show you that one in a minute, it's 0.004. So that's important for us to know. Okay. So, whoops, picked the wrong one. And go back to this. So this one, since it's these large squares, this is 0.1. Okay, and I think it's centimeters cubed. Ooh, did I look at that right? I don't always. Yeah, they don't even have it on there. That's okay. Not a big deal. You have to know it's 0.1. So we're going to go ahead and we're going to write this out. So average number of cells. We didn't average them. We're going to go ahead and total them, but I am going to show you how we can make this different. So let me go ahead and erase this for a minute. So we're going to do this. So we have 5, 10, 15. We actually have 19. So we're going to go with 19. Okay. Dilution. Do we have a dilution here? Oh, let's read our problem. We do. The specimen was diluted 1 to 200. So we got to make sure we put our dilution in here times 200. Okay. Now we're going to divide by the number of squares counted, which is 4, times 0.1. Okay. So let me get my calculator out. We'll have I don't do manual math very well. 19 times 200. Okay. We're going to have 3,800. We're going to divide that. I could do this one in my head, but we'll just make sure because I always second guess myself. So now we'll take 3,800 divided by 0.4, and our count is 9,500. So what I want to show you now is how you can do this different ways with the same count. Okay, let's think about our 19 here. So that's 19 in 4 squares. So let's do 19, let's divide that by 4, and that is 4.75. Okay, that's cells counted, times 200. Now when we talk about this on the bottom, okay, our calculation up here says number of squares counted. Well, this right here, our 4.75, is an average for 1 square. So we'll put our 1 there, which we really don't need to. We'll times that times 0.1. Oh, let me go ahead and put that up a little bit so it'll print. And so let's multiply this out. 4.75 times 200. Look at this. 950 divided by, let's think. Let's refresh our math skills. What is 1 times 0.1? Yes, it's 0.1. So let's take our 950 divided by 0.1, and, oh, my pencil doesn't want to work. I accidentally put the eraser on, equals 9,500. Okay, so this is where I want you to really make sure you're putting the right things in this, okay, calculation. So the other thing we could do, which we don't have the count here right now to do it, is you actually could be doing total squares. Because I said you had 2 sides, if you counted 8 of those, okay, and you put 8 on the bottom, okay, times your 0.1, and you put the total number, which probably would be around 40-ish, okay, 40 times 200. So let's do that real quick. It's not going to be exact but it will be close. 40 times 200, whoops, I plugged that in wrong. Okay. And that's going to be divided by 8 times 0.1, so 0.8, and that is going to equal out to be 10,000. So you can see how it's close. This and this in that difference, it's not clinically significant for the patient. Okay, so let's take a look now at our red cells. I tried to make these as close as possible as I could. Okay, so here's our red cells. Red cells are a lot smaller, so what we end up doing is counting red cells. Then we're going to use this center square here. I probably should make my highlighter just a little bit smaller for y'all. And then we're going to count these 5 squares. Okay. So this is how we do a red cell count. So in this instance, let's go ahead real quick and we will see what we get on this one. Again, we would typically have 2 sides, but we're just going to do this with what we have. So in here, you would count, again, red cells are going to be a lot smaller, so you would follow your same progression through here and go back and forth along like this, okay? And you would count those. And you can see we're not going to have nearly the amount of cells to count. Where if you were counting these great big cells here, oh, you'd just be counting cells forever. And we don't want to do that. We don't have time. to count cells forever. So we're going to end up with 1, 2, we're not going to count any in there. We'll go ahead and count this one 3. So we honestly only have 3. Okay, so we have 3 cells times, let's go back up here, 3 times our dilution factor. In this case, it's 10. We're going to divide by, and see, these boxes are much smaller, so they are 0.00. Oh, sorry, I'm getting a little sloppy there. 0.004. So 0.004, and we counted 5. Okay. I think I wrote this backwards from how I wrote it up here, but okay. So let's go ahead and calculate this out. And we're going to have 3 times 10. Okay, I don't have to do that one with the calculator. 30 divided by 5 times 0.004. This is 0.02. Okay, 30 divided by 0.02 equals 1,500. Now you can see how this is saving us an immense amount of time. Can you imagine sitting there and counting 1,500 cells? No, of course not. So the Hemacytometer is your friend. Yes, it can be a little difficult learning how to use, but once you get the hang of it and you start doing it, and you really think about what these things mean, it's extremely helpful. Okay, and we'll end with my little smiley face again. Great job, guys. Hopefully we get to see each other soon.